All right, I'm going to continue on with this test review, starting with number 11 here. And number 11 says, solve log base 5 of x plus 2 minus log base 5 of 11 equals log base 5 of 121. We're going to essentially cancel out these log base 5s, but before we do, we need to condense these two. And since it's subtraction, we're going to condense them by way of division. So I'm going to make this log base 5 x plus 2 divided by 11 equals log base 5 of 121. And when I do that, I can essentially cancel out these log base 5s, since there's one on each side, leaving me with x plus 2 divided by 11 equals 121. So we're going to solve for x. That's what it means when it says solve. So I'm going to multiply both sides by 11 to give me x plus 2 equals, let's see, 121 times 11 is 1311. And to get the x by itself, we simply subtract 2 from both sides to get x equals 1,329. Next one's significantly easier than that. It says solve log base 5 of x equals 2. Well, we want to rewrite this as an exponential, so to get rid of the logarithm. So I always start with the 5, the base, so this is 5 to the second power equals x. So I just rewrote it from a logarithm into an exponential. And of course, 5 squared is just 25. So we're doing lots of solving here. Solve this next one. Log base 5 of x squared plus 9 equals log base 5, 34. That's an interesting one. We've got logs on both sides. Log base 5s, they're the same base, so we can essentially just ignore them. They're going to cancel each other out, leaving me with x squared plus 9 equals 34. What I'm going to do is subtract 9 from both sides to get x squared equals 25. And then I'll take the square root of both sides to get x equals 5. Okay, it's the opposite of square is square root. Number 14. Oops, what did I forget? When you take the square root of both sides, it's positive and negative 5. Now, you might be inclined to get rid of that negative 5 because, of course, you can't have a negative logarithm. But in this case, negative 5 squared is still 25. So there is two solutions here, positive and negative 5 for x. On this next one, we're solving for n. And this is 6 to the n minus 9 power equals 1 over 1296. We want to get the bases the same here. So I want this to be 6 to the n minus 9 equals 6 to the something. So this is where I like to use this power table. And I'm looking at the powers of 6. Powers of 6, 1296 is 6 to the 4th power. But that 1296 is on the bottom of the fraction, so we need to make that to the negative 4th power. And once I do that, I can see that the two bases are the same. They're both base 6. So I can set the exponents equal to each other. N minus 9 equals negative 4. Add 9 to both sides to get n equals 5. Here's your solution on that one. Write the expression for number 15 as a single logarithm. 5 log base b of v plus 7 log base b of w. Well, the bases are the same, so I can condense them into one logarithm. But before I do that, I need to get rid of that 5 and that 7. And this is that special rule of logarithms where you can take whatever's out front and move it up into the exponent, which is what I'm going to do. Log base b, v to the 5th, move that 5 from the front up in the exponent, plus log base b of w to the 7th. Now, since they are the same base, I can go ahead and write them as a single logarithm, log base b of, and since it's addition, we're going to combine them using multiplication. So this is v to the 5th times w to the 7th. Don't forget your equal signs. And this is the most simplified form right here. Number 16. There were 417 cell phones sold at an electronics store in January. Since then, cell phone sales at the store have increased at a rate of 3.75% per month. At this rate of growth, which function can be used to determine the monthly cell phone sales m months after January? This is from the formula chart right here, y equals ab to the x. And I'm going to start with a y equals, and the a is how many cell phones you started with. Your starting point, which is 417, times b to the x power, but here instead of x, they've got an m for months, so we're going to use m instead of x. The question is, what goes in the parentheses there? Well, it's increasing at 3.75%. And to figure out what goes in the middle there, you're going to do 1 plus, because it's growing, 1 plus that 3.75 divided by 100. And that's what goes in the parentheses there, 1.0375. 1.375. Now remember, if it was decreasing by 3.75 per month, we would have done 1 minus. And that would have given us the decimal. But it was growing, so that's why I used the top one instead of that 0.9625. All right, let's talk about number 17. And 17 says, this is a transformation one, describe the transformation of f that results in the graph of g. So I've got this f of x equals 1/2 to the x power, and this one is 1/2 to the x plus 5 power minus 1. So I see two transformations here, and we're going to describe both of them. That plus 5 is either left or right because it's up next to the x, but when it's next to the x, it's always counterintuitive. So it's not right 5, this one is left 5 units. And that minus 1 is up or down, and minus means down 1 unit. And that's it for number 17 there. 18 says, evaluate the expression log base 2 of 1 over 64. Now, you can do that by hand if you'd like, but my recommendation to you is to just use the change of base formula and type it in the calculator. So to do that, you would do log of 1 over 64 divided by log of 2. That's your change of base formula. Log of BA equals log of B divided by, log of A divided by log of B. Okay, so let's type that in. Log of 1 divided by 64 divided by log of 2. And for number 18, that's going to spit out -6. So you could use your power table and try to figure all that out, but my recommendation to you is just type it in the calculator. Save yourself some time. Find the x or y intercept in number 19 for the equation y equals 2 to the power of x minus 3. Again, this is calculator work, so I'm just going to type it in the calculator and graph it, but it's important that you know how to type it in, so let me show you that. Y equals 2 to the power of x, and I'm going to put all of that in parentheses. 2 to the power of x minus 3. Oops. Make sure you can see that. And so I can go ahead and graph this thing to figure out if it has an x-intercept or a y-intercept. And it's clearly got a y-intercept. The question is where. And I'm going to go to the table. And remember, the y-intercept occurs where x equals 0. And in this case, it occurs at 0, -2. which is the answer here. It's a y-intercept, and it's at 0, -2. Number 20, and this is the last one I'm going to do on this video, says evaluate the expression log base 10 of 1,000. This is a pretty easy one to do on the using this power table, but despite that, I'm still going to do it in the calculator using the change of base formula. I'm just going to type in log. Actually, this is already in log base 10. So in the calculator, all you have to do is log of 1,000. You don't have to do change base here because the calculator is log base 10. So all you need to do is type in log of 1,000 to get 3. Because the calculator is already in log base 10. Alright, that's it for this video. If you're looking for numbers 21 through 30, watch the next video. Thanks.